Let's take a look at a really common type of sequence called arithmetic sequences. I have an arithmetic sequence listed here. It's the sequence of numbers. It starts at -5 and then goes to -2 and 1, 4, 7, 10. You might be able to guess the next number would be 13 and then 16. And an arithmetic sequence is a sequence where each two consecutive terms has the same difference. Now remember, difference means to subtract. So if I'm looking at that, 4 and 7, 7 minus 4 is 3. And if I'm looking at, like, let's say 10 and 13, 13 minus 10 is also 3. And if I'm looking at 1 and 4, 4 minus 1 is 3. And even -5 and -2, -2 minus -5 is 3. So this 3 right here is what they call the common difference. And the letter that we use for the common difference is D. We would say that D is +3 in this case because the terms in our sequence are going up by 3. Let's look at another example. Let's say that we had the sequence that starts at 30 and then goes to 28 and 26 and 24 and 22 and so on. So in this one, there is a common difference because if we subtract each 2, we're going to get always the same number or the same difference. But this sequence is going down by 2 each time. So if we did the latter minus the former, 28 minus 30, we'd get -2. And if we did 22 minus 24, we'd also get -2. So in this case, the common difference is -2 because this sequence is going down by 2 each time. Now, one thing that we need to do with sequences very frequently is write a formula for the terms of our sequence. And we could write a formula, let's say a recursive formula, for a sub n, because each term, you just take the term that came before it and add 3 to it. So if you want, let's say, the third term, take your second term and add 3. Take -2 and add 3, and you'll get 1. You'll get your third term. The problem, like we talked about in the previous video with a recursive formula, is if we wanted to know the 100th term, well, we would have to have the 99th term and add 3 to it, and I don't know the 99th term. I've only gone up to 1, 2, 3, 4, 5, 6, 7, 8 term. I don't want to list out 91 more terms to get there. So instead of having a recursive formula, we generally would like to have an explicit formula. Okay, so I'd like to clean up this page a little bit, but leave the 2 examples there and come up with explicit formulas for each of these 2 examples. Great. Okay, so for each of these, let's find an explicit formula for a sub n. Okay, there are 2 pieces that we need to find an explicit formula for any arithmetic sequence. We're going to need the first term and the common difference. Those are the 2 things we need. And fortunately for this one, we have each one of those. We have -5 and we have 3. And if you'll permit me, for this first example, I want to show you where the formula comes from that we're going to use for our explicit formula. So over here in red, I'm going to list out the formula or the sequence like this. Our first term is -5, and our second term we get by taking -5 and adding 3, because that's our common difference. So we get -2. Our third term we get, I know that we take -2 and add 3, but in order to show you where the formula comes in, I'm going to write it like this. -2 came from -5 plus 3. But we had to add on another plus 3 to get to 1. So the -5 plus 3 came from our -2. To get the fourth term, we're taking 1 and we're adding 3 to it. But 1 came from this thing. It came from -5 plus 2 3s. And then we have to add on a new plus 3 for our common difference. So -5 plus 3 plus 3 plus 3 is basically 1 plus 3. Here's 1, which is 4. And I'll write one more out. A5 is 4. Well, 4 is this whole thing. It's -5 plus 3 3s. Whoops, I wrote too many 3s. But we need to get the next term, so we do need to add on another 3 to get the next term. This will give me 4 plus 3, which is 7. Okay, here is the shortcut that we want to notice here for our a sub n's. Every time we're writing one of these out, this a sub 5, we're starting with our first term, -5, and we're adding on 1, 2, 3, 4 3s. If you do the arithmetic real quick, that's -5 plus 12. Yep, that works out to be 7. Look at the a sub 4. That's the first term, -5 plus 1, 2, 3 3s. A sub 3 was, oh, I made a mistake. A sub 3 was, oh no, I didn't. I just wrote it in the wrong spot. A sub 3 is -5 plus 2 3s. So each time we're coming up with our new a sub n, we're starting with our first term. We're adding on a bunch of 3s because 3 is our common difference. And if you look and figure out how many 3s we're adding on, notice it's always for the fifth term when n is 5, we're adding 4 3s. For the fourth term when n is 4, we're adding 3 3s. For the third term, we're adding 2 3s. So this number, however many 3s we're adding on, is always 1 less than what we're looking for. So 1 less than n is n minus 1. So the formula that we're going to use as an explicit formula for an arithmetic sequence is your first term plus n minus 1 times your common difference. And you can use that formula for every single arithmetic sequence that you would need. Okay, so let's do that for this very first example here. A sub n would be your first term, which is -5, plus n minus 1 times the common difference, which we know is 3. And that's a pretty unsimplified version of that, but that'll do. Let me simplify it a little bit. -5 plus 3n minus 3 gives a sub n is, let's see, -5 and minus 3 is -8. So 3n minus 8. Okay, I'm going to come back to that formula in just a second, but let's do the second problem. So let's find an explicit formula for a sub n using the hard work we already did all over here, using this formula we have here in blue. So our a sub n is equal to the first term plus n minus 1 times the common difference. So that would be, first term is 30, n minus 1, the common difference is negative 2. And there's an unsimplified version for our explicit formula for a sub n. Let's clean that up just a little bit, distribute the negative 2 through. So a sub n is 30 minus 2n plus 2. So maybe writing it as negative 2n plus 32. Okay, some really cool things I'd like to point out here. First interesting thing to point out, in the explicit formula, notice how you have a linear equation. A sub n is 3n minus 8, or negative 2n plus 32. That should feel really similar to y equals mx plus b, because it is. It's a linear equation. The second thing I want to point out is the slope of that equation. The 3 for the first problem and the negative 2 for the second problem, no coincidence, it comes from your common difference. So the common difference will always be the slope of that linear formula. What is a little bit more difficult to figure out is what the plus b part is, and that's why you need the rest of this formula. So that's one really neat thing that I want to point out. The second really neat thing that I want to point out is, now that we have an explicit formula, now we can do a second follow-up question to this. We could now find the 100th term for each of these. So if we know that a sub n for the first one is 3n minus 8, a sub 100 is 3 times 100 minus 8. So 300 minus 8 is 292. Without doing any of this long work of listing out all 99 terms and then adding 3 to the last one. And down here we could find, if we wanted to find the 100th term, negative 2 times 100 plus 32. Negative 200 plus 32 is negative 168. And we did that really quickly. So having an explicit formula for these sequences is really useful in finding large terms down the line in our sequence. Let's do the same type of problem, but in a slightly different manner. So let's still find an explicit formula, a sub n, but now instead of being given the terms of the sequence, we're just told that a sub 4 is 3 and a sub 20 is 35. Okay, so I want you to remember two things. First of all, our formula for a sub n. A sub n is the first term plus n minus 1 times the common difference. And if we're going to find that a sub n, we really need to have a1 and d. So here's what we're going to do. We're going to use our two equations. A4 is 3 and A20 is 35 to come up with a way of figuring out A1 and D. Okay, so here we go. If A4, is 3, that means A1 plus, let's see, 4, n is 4 here, 4 minus 1 times D. In other words, 3 equals A1 plus 3D. Whoops. Highlighter. There we go. from our first equation. From the second equation, A20 is equal to 35 means A1 plus 20 minus 1 times D is 35. And simplifying that, that means that 35 is equal to A1 plus 19D. So what we have now from the first two, A4 equals 3 and A20 equals 35, is we have two equations and two variables, and we can take them over here and solve those. So let's see. I'm going to move this around so it's in a little bit nicer format to solve. I'm going to write A1 plus 3D equals 3. And then I'm going to write for the other equation A1 plus 19D equals 35. Okay. So to solve this system of equations for A1 and for D, I'm going to use the addition method because those A1s are going to cancel out really nicely. And I'm going to multiply the top equation by -1 everywhere and add these together. If you don't remember solving by the addition method, see my earlier videos for solving systems of equations. Okay, the point is when we add these two together, the A1s are going to cancel to 0, which is lovely. We have -3D plus 19D makes 16D, and 35 and -3 makes 32. Dividing both sides by 16 gives us D equals 2. Great, first one done. Now to find the other variable, to find the A1, we're just going to plug D equals 2 back into any of our equations that have A1 and D. I think I'm going to use this equation right here. So we would have 3 equals A1 plus 3 times D, which we now know is 2. So 3 equals A1 plus 6. So A1 is -3. So putting those together, we have in our AN equals A1 plus n minus 1 times D, we have A1 is -3, n minus 1 times D is 2. There's an unsimplified version of our formula, and if we distribute the 2, we have AN equals -3 plus 2n minus 2, or in other words, A sub n equals 2n minus 5. These are really easy to check to see if we did them correctly. We can plug in A4 equals, and see if we get out 3. So if we did a quick check, A4 equals 3, we're going to plug in n equals 4. So A4 is 2 times 4 minus 5, which is 8 minus 5. Oh, thank goodness. We get 3. And we can check the A20 equals 35 as well. So quickly to recap what we did here, if we're given 2 entries in our sequence, we want to find A1 and D so we can use our formula for an arithmetic sequence. AN equals A1 plus n minus 1 times D. So plugging in what we know n is equal to 4 and the entry A sub n is equal to 3. So A4 is 3, means A1 plus 4 minus 1 times the common difference D. We get one equation with A1 and D unknown. Then we plug in n equals 20 and A sub n equals 35 into the other equation, come up with a second equation that has A1s and Ds. And then we use what we know how to solve for systems of equations to figure out what A1 and D are so we can plug them into our formula. Let's try one more example. Okay, let's find A sub n if A sub 30 equals -18 and A sub 72 equals -60. All right, now remember, we need to use A sub n equals the first term, whatever that is, plus n minus 1 times the common difference. Okay, so let's get our two formulas like we did last time. Let's start with this first one. A sub 30 equals negative 18 means negative 18 equals A1 plus, that's the 30th term, so 30 minus 1 times D. Negative 18 equals A sub 1 plus 29D. Okay, there is my first equation. All right, second equation. Oops. Second equation. We have negative 60 equals A1 plus, let's see, n in this case is 72. 72 minus 1 times D. So negative 60 equals A1 plus 71 times D. So now I have our second equation. Putting those together, got negative 18 equals, I'm going to write it the other way. A1 plus 29D equals negative 18. A1 plus 71D equals negative 60. Again, fits beautifully with the elimination method. I'm going to multiply the top equation by a negative 1, which would make this last one into a positive 18. Add so that the A1s cancel to 0. Let's see. 71 minus 29 makes 42D. And positive 18 plus negative 60 is negative 42. So we get D equals negative 1. And then remember, to figure out what AN is, plug that into any equation that has A1 and D. So I think I'll use the top equation just because the numbers are a little smaller. A1 plus 29D, so 29 times negative 1, equals negative 18. A1 minus 29 equals negative 18. And when we add 29 to both sides, get 11. So A sub n equals A1, 11, plus n minus 1 times D, which is negative 1. So that means A sub 1 is 11 minus n plus 1. So A sub n is negative n plus 12. And just like in the last example, you should be able to check these really easily, picking one of your two sequence entries and plugging in the numbers. So if we pick A sub 72 equals negative 60, if we're going to check, this is our n value, and that's our A sub n value, negative 60. So let's plug in n equals 72. A sub 72 equals negative 72 plus 12. Yep, sure enough, negative 72 plus 12 is negative 60. So it checks.